Imagine spending billions of dollars building the perfect electric car, only to watch one company reveal a tiny engineering breakthrough that instantly makes years of your work look outdated. That is exactly what happened when Tesla unveiled its latest electric motor. At first glance, it looked like another product presentation, a few technical upgrades, a few impressive numbers, and business as usual. But engineers saw something completely different. Hidden inside this motor is a carbon fiber sleeve so advanced that it allows the rotor to spin beyond 20,000 revolutions per minute, helping push the Model S Plaid from 0 to 60 miles per hour in under 2 seconds. Even more surprising, Tesla published the patents for everyone to see. So if every automaker can study the design, why can't they simply build the same motor? The answer has almost nothing to do with the blueprint and everything to do with manufacturing. Let's find out why. For over 2 decades, Tesla has been rewriting the rules of the automotive industry. Back in the early 2000s, electric cars were widely seen as slow, impractical machines with limited range. Few people believed they could ever challenge gasoline vehicles. Then Tesla arrived with a different vision. The original Roadster proved electric cars could be exciting. The Model S showed they could outperform luxury sedans. The Model 3 brought EVs into the mainstream. While competitors rushed to copy each success, Tesla quietly kept working on its next breakthrough. That breakthrough is the motor you're looking at today, and it could be one of the company's biggest engineering achievements yet. To understand why this motor matters so much, we first need to look at one of its smallest components. Every electric motor has a spinning part called the rotor. As the rotor spins faster, the motor produces more power. Sounds simple, but there's a problem. At extremely high speeds, enormous centrifugal forces begin pulling the rotor apart. Traditional steel designs eventually reach a limit where heat builds up, efficiency drops, and mechanical stress becomes difficult to control. For decades, engineers accepted those limits. Tesla didn't. Instead of redesigning the entire motor, Tesla focused on strengthening the rotor itself. Their solution? Wrap it inside an ultra-strong carbon fiber sleeve. Carbon fiber is incredibly light, incredibly stiff, and exceptionally strong under tension. As the rotor spins, the sleeve compresses and stabilizes it, allowing it to safely reach rotational speeds that conventional designs struggle to achieve. That means more power, faster acceleration, higher efficiency, and greater stability under extreme loads. It's a small change with enormous consequences. But here's where the story becomes even more interesting. Knowing the idea isn't the same as being able to build it. Carbon fiber and metal expand differently when temperatures rise. If the sleeve is wrapped even slightly wrong, microscopic imperfections can appear. At 20,000 revolutions per minute, those tiny errors become catastrophic. That's why Tesla didn't just invent a new rotor. It had to invent a completely new manufacturing process. Highly automated systems precisely control fiber tension, wrapping angle, temperature, and alignment throughout production. Every finished rotor is then inspected with extreme precision before it ever reaches a vehicle. That's the real secret. The patent explains what Tesla built. It doesn't explain how Tesla consistently manufactures thousands of them with microscopic accuracy. And that's a much harder problem to solve. Before we continue, if you're enjoying these deep dives into the technologies shaping our future, make sure you subscribe to Modern Discovery. We break down the engineering, the innovation, and the stories behind the world's biggest technological breakthroughs. Of course, none of this means Tesla is unbeatable. In fact, the company still faces some serious challenges. Carbon fiber manufacturing is expensive. Scaling this technology across affordable vehicles like the Model 3 or Model Y won't be easy. Meanwhile, Tesla continues facing intense price competition from rapidly growing Chinese manufacturers. Companies like BYD are producing millions of electric vehicles at remarkably low costs while expanding across global markets. At the same time, Tesla still has to deal with shrinking profit margins, increasing competition, and continuing pressures surrounding full self-driving. Having the best technology doesn't automatically guarantee market dominance. History has proven that many times before. So how are Tesla's competitors responding? Lucid continues building some of the most technically impressive luxury EVs on the market, but production volume remains limited. Rivian has earned a loyal following with electric trucks and SUVs, yet its motor technology still follows more conventional designs. Traditional giants like Ford and General Motors are investing billions into electrification, but balancing gasoline vehicles alongside EV development makes rapid innovation much more difficult. Then there's BYD, arguably Tesla's biggest global rival. Its manufacturing scale, battery production, and supply chain efficiency make it an incredibly dangerous competitor. But outside China, Tesla still holds major advantages in software, brand recognition, and charging infrastructure. Right now, no single company matches Tesla across every category at once. And perhaps the biggest story isn't even about cars. A lightweight motor capable of delivering enormous power while remaining efficient could reshape industries far beyond transportation. Electric aircraft, industrial automation, renewable energy systems, large-scale power infrastructure. These technologies all depend on high-performance electric motors. If Tesla can eventually manufacture this technology at massive scale, its influence could stretch far beyond the automotive world. Instead of simply building electric cars, Tesla could end up supplying the technology powering an entirely new generation of clean energy systems. That's a much bigger game. So, has Tesla just taken another massive leap ahead? Absolutely. But history also reminds us that today's leader isn't always tomorrow's winner. BlackBerry once dominated smartphones. Nokia seemed impossible to beat. Entire industries have changed almost overnight. The electric vehicle race is still unfolding. Battery prices continue falling. Governments continue changing regulations. New startups appear every year. And somewhere, another engineering team could already be working on the next breakthrough, one that nobody sees coming. So maybe the real question isn't whether Tesla has already won, it's whether everyone else can catch up before Tesla moves the finish line once again. What do you think? Has Tesla created an advantage that competitors simply can't overcome? Or do you believe another company is preparing a breakthrough of its own? Let us know down in the comments. If you enjoyed this deep dive, don't forget to leave a like, subscribe to Modern Discovery, and we'll see you in the next exploration of the technologies shaping tomorrow.